Yes,
Yeah,
3
I was
var.
about to remind you.
Yes, 3 var k map. For example, what is the example I can find you? Function of x and y and z is equivalent to I is equal 0 to 7, and the location will be 3, 4, 5, 6, and 7. Okay, so normally what we can do, we're gonna make a table 1, 2, 3, 4, and since the left to the right, so gonna be here x, y, z, 0, 1, and then 0, 0, 0, 1, 1, 1, 1, 0. Everybody agrees me? That's how we sorted from the last time. So gonna be here 0, 1, 3, 2, 4, 5, 7. Right? Now we're gonna go ahead and just like change, and we put the values. So where is 3? It will be here is 1, 4 it's gonna be 1, 5 is gonna be 1, 6 is gonna be 1, 7 is gonna be 1. Everybody agrees with me? So since we have 3 variables, so that means we can have 2 or 1 or 4 or 8 can be grouped, right? Those all the possibilities this table can give us. Because here we have 0 and 0 and 0. Everybody agrees with me? So what we have here is the following, right? If I can use highlighted color in a different one, so basically I have those 4 together. Those 4, right? Then the only one is missing this guy. But I'm looking for optimization. So that means I will see is any neighbors, even from the old group, can be participating. So it's gonna be group 1. So now I can just go ahead and change my color to be here as a group 2. Right? In that case, I can come and say f as a function of x and y and z is equivalent to group 1 or group 2. Right? Now, let's go into the trick we learned about horizontal vertical. So maybe I can ask Jennifer. Jennifer, can you give me the can you tell me what this group 1 is? Hello? Oh, that's fine. Okay, maybe we can ask Christopher. Christopher. Yes, can you please go ahead and tell me what this group 1 will be? Just guess how it will be. So remember, when we it's gonna be X. Do you guys agree with him?
Yes.
Yeah, just X.
Let's see. What was our rule? What was our rule? We go first, horizontal, and then we'll go vertical, right? This vertical thing, because they are different than each other, it's gonna end up being 1, right? And the horizontal is just looking into X, so basically it's X. So Christopher is right. Now let's go in the group number 2. So maybe I can ask Griffin. So what will be group 2?
Group 2 would be YZ.
YZ. Wow, you guys are very good. So please, everybody, support, Christopher and, Griffin. You guys are doing a great job. So is it clear to everybody?
Yeah, for me at least.
It's super clear, right? Okay, now we can try more different stuff, You know what? Here's a very good question. 1, 2, 3, 4. X, 5. What is this? Huh? Somebody tell me.
Checkerboard.
Exactly. Nicholas?
Surrogates, X, X or Y, X or Z.
Whoa, again? That will be what?
X, exclusive or, yeah, that one. Y, exclusive or Z.
Can I choose the next example? Yes, Luai. Go ahead. So I will give you can I make the example for you and you can try? Okay.
Oh no, I want to choose the example.
Tell me what was the example. Huh? Here's the table.
So on 0.
Wait, just wait. 0, 1, 3, 2, 4, 5, 7. Okay, go ahead.
So for the 0, we're gonna have 1.
Okay.
And 2, we're gonna have 1.
Okay.
And 4, 5, 6, 7, we're gonna have 1.
Like this?
Yeah.
And those zeros, right?
Yeah.
We can think about it as the following, right? This one is group 1. Do you guys agree?
Okay.
Huh?
I do agree.
Okay. Now the second group will be fun, you know. Look at this. That's group 2.
Oh, we try to group like as much as we can.
Exactly.
Okay.
So in that case, you know, maybe we can ask somebody, you know, not you. Group 1, Nicholas. Can you hear me? Okay, maybe I can ask Vincent. And Nicholas, can you tell me group 1?
X, right?
Yes, can you tell me group 1 what it will be? X, okay. Then, you know, Vincent, can you tell me group 2 what it will be?
Well, I don't want to do group 2 with the, like.
We can try it together if you want. Do you want my help?
Yeah.
Okay, so this is horizontal like this. So that means X is 0, X is 1, so they're gonna be 1, right? So you can basically write it like this. Then, you know, you're looking for the vertical, right? So the vertical is gonna be this 2, right? So in that case, you know, Z is 0, Z is 0. So basically gonna be Z complement. And then, you know, ended with X, Y is 0, Y is 1. So gonna be Y complement Y. Which is equivalent to X. And then, you know, this is 1, so gonna be Z complement.
Professor,
Yes.
is there like a, let's see, is there a name to what group 2 is? Like, is there like a formal name for what that thing is?
Yeah, those are edges, basically.
There's okay, that's called edges. Yeah.
Edges, yes.
All
so
right.
The edges is basically, you can consider like the Earth. When it go on like this in the shape, right? You'll find out whatever was far from here, it's gonna be close to it, right?
All right, awesome. Okay, thank you. That's interesting.
Now, let me show you something actually even more fun. No, actually, this is whatever we can get. Let me give you a very practical example of implementation of something, right? How many of you heard about something that's called majority encoder? I will just give it to you as an exception. It's coming from chapter 5, but you know, I will tell you what it is. So imagine that somebody's telling you design 3 input variables majority encoder. Okay, design 3 input variables majority encoder. Everybody hear me, right? So what I will think about it, I want to make the gate level implementation. So I'm looking for what? Gate level implementation of 3 input majority encoder. Everybody hear me, right? Now, what I would like to do, I would like to translate what is this, right? So I have here a box, and this box has 3 inputs, and I will call it ABC. Sounds good? And that box is called majority encoder. When I say majority, that means I'm expecting the output to be 1 output, and that output will be the collection of the something of this A and B and C. Okay, so let's call this output what? OP. Okay? Now, when you say majority, what is majority? Is it majority of ones or majority of zeros? Can you hear me? Is it majority of ones
Yes.
or majority of zeros?
Should be zeros.
Majority of ones. That means, you know, I'm looking for every single state. If majority of the state of the variables are ones, the output will be one. If not, it will be zero, and the vice versa. So let's translate this. If I would like to describe what is inside this block, what I need to do, I need to make a truth table. Everybody agree? That's basically our footstep of building the implementation of any circuit. So gonna be here A and B and C and OB is the output, right? Since I have a 3 input variables, so what I'm expecting, how many states it should be? It should be in 8 states, right? 1, 2, 3, 4, 5, 6, 7, 8. Right? Now I'm gonna be 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1. 1, 2, 3, 4, 1, 2, 3, 4, M0, M1, M2, M3, M4, M5, M6, M7. So far, so good? Hello?
Yes, sir.
Okay,
Yes,
now,
sir.
yes, I want to see what is the output will be. So basically, definition of majority encoder, that means the output will be equal 1. If the number of ones here, it will be higher than number of zeros. That's called majority encoder for active low, basically, or majority encoder for ones. So in that case, you know, all of those are zeros. There is no ones, right? So that means how many ones I have there? 0. How many zeros I have there? 3. So that means the output should be 0. Sounds good? Now I find out in the second state, two of them are 0 variables, while one of them is 1. So 1 less than 2 is 0. So that's still 0. Then in the second one, same thing. Third one is a little bit different, right? Yes, exactly. It's equal 1. Why? Because, you know, 2 ones versus 1 0. So it's going to be 1. So now, you know, there in the 4, it's going to be 0. In a 5, it's going to be 1. And then the 6 is going to be also 1 because 2 ones versus 0, 1 0 is going to be 1. And 7 is going to be 1. Do you guys agree? Because 3 versus 0, 0. Basically going to be what? 1. So far what we did now, we made a footsteps for designing a gate level implementation. So now we need to apply the optimization we learned. So either that I'm gonna take all of these pieces and I put it together and I use the postulates and all of this Boolean algebra, traditional ways of optimization, or I will use K-map. So in that case, I have to use K-map as it's more efficient as we have seen, right? So I will open here my table like this, 1, 2, 3, 4, and then, you know, I write here, and it's gonna be from the left T to right, so gonna be here A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. This is 0, this is 1, this is 3, this is 2, this is 4, this is 5, this is 7, and this is 6. You guys agree with me? Now we're gonna start putting the ones and zeros in the table so we can see what optimization we can get out of this, right? So if you look at it very well, so 3 is equal 1, 5 is equal 1, and 6 is equal 1, and 7 is equal 1. Anything else is equal 1? I don't think so. The rest are zeros. So how many groups I should have out of this K-map? Somebody tell me.
3.
3. So basically F, or as a function of A and B and C, is equal OP is equal to 3 groups. Going to be, this is group and this is group and this is group, right? So we're going to have group 1 odd with group 2 odd with group 3. Everybody agree with me? Now I can go very easy and say that I will apply my K-map knowledge, and maybe we can also practice, because this is the most important thing for me to practice. This is group 1, this is group 2, and this is group 3. So let me ask randomly by somebody to do it. So Jennifer, can you please give me what is the G1 will be? Jennifer? Take your time. They're gonna be A. That's A, or do you think something else will come in? AC. Everybody agree with her?
Yes.
Nicholas, do you think she's right? Nicholas? Okay, perfect. So she's right. Now maybe we need to ask somebody randomly because I have a lot of you guys. So I need to. Landon, can you tell me what is group 2 will be? Landon? AB. Do you think he's right?
Yes.
Yes.
He's right. Maybe Jeremy, can you tell me what is group 3 will be?
BC.
BC, yes. Do you think he's right?
Yes.
Perfect. So, did you see what we did? We so far, we use the knowledge of many things. We use the knowledge of the twist table. We use the knowledge of fully understanding what is the problem is in the design. And we, one second. Okay, and now, where is it? So we're saying what? Now we need to make an implementation. Guess what we're gonna use? We're gonna use whatever we learn about the gates of equivalency, right? And we learn about all of these things, right? So basically, if I will tell you, can you please make a full implementation using NAND gates? What you're gonna do? So we're gonna be sure to implement any AND gates with NAND and any OR gate with NAND. You guys remember that? We can try to do it together if you want. Should I do it?
Sure.
So if I would look to the AND, I don't remember how the AND looked like. AND is basically X, Y like this, right? But I want to use NAND, but NAND is like that. So that means, you know, if I want to build an AND, I have to build it like this. Right? Because, you know, it's like this, and then, you know, here it's gonna be like that, which is equal to X. Right? Now, if I would like to build an OR gate, so my OR gate is like this, which is equivalent to, is this correct?
No.
Is this correct?
Yes.
Very much so.
Yes. So in that case, OR gate, it will be like that. Right? Now we're gonna take all of those guys and start implementation. So we said A and C are ANDed, right? It's A and C are ANDed, and the output will be something. Let's call it T1. Then you know A and B are ANDed, so basically it's gonna be the same. Right, and let's call this what? T2. Then you know B and C are ANDed, right? Correct? Now we haven't tied them to OR gates. So, you know, we need an OR gate here. So basically we can go ahead and do what? Right? Then we can take this one into another OR gate level. And that will be my, everybody agrees me?
Yep.
Is there any room for optimization?
Yes.
Okay, give me a room for optimization. Which one?
The bottom branch where you wrote T3, those two NAND gates where it's self-inputted kick
You mean
outs.
like
Yep.
this?
Yep.
That's it?
Same with T1 and T2.
Yep.
So what does the final circuit should look like? It will be like that. And right? A and B. And the other side, the other branch is going to be A and C, and A and C, and B, and then B and C, right? And that is how many gates we use for this implementation? 1, 2, 3, 4, 5, 6. We use 6 NAND. Have you noticed something? What is the longest path we have here? Do you remember when I told you about the critical path? Do you remember this or not?
The
Yeah.
first one from A to Z.
Yeah.
Right? This one and also this one. Both of them are equal, are they not? Right? What is the shortest one? This one. Oh, sorry. Okay. So far, so good. Everybody aligned with what I'm doing? So you understand what I'm saying? So the message I convey here, I can come and tell you implement a certain thing using this number of gates, right? So then, you know, at least you can go ahead and start the process by understanding what is this. You make the right truth table. From there, you can go ahead and you start your optimizations using the K-map. And from there, you can go into the implementation and you can also calculate the critical path. Or I will ask you to calculate, then you will calculate. If you have any questions, you know, don't hesitate, stop me. I will be more than happy to assist you. Good? Okay, we can try now different thing, which is the four variable K-map. Four variable what K-map. So four variable K-map, that means is covering how many states from your point of view?
16.
16, right, correct. So imagine that, you know, I have a table like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And that's basically A, B, C. This is Z. So that means 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, Sounds good? Now going to be the M0, M1 up to the M50. How can you build the array or the K-map? It's going to be 4 by 4, right? So one, I'm not sure what it is, but it's 1, 2, 3, 4, 1, 2, 3. Left to right, so going to be what this time is A, B, C. So we're gonna do exactly as we did on the. Do you remember the 3 variables? Do you remember there when we said 0, 0, 0, 1, 1, 1, 1, 0? We're gonna do the same thing in the bottom. So it's gonna be also 0, 0, 0, 0, 0, 1, 1, 1, 1, 0. All that will be a little bit tricky, right? Look, so that's 0. This is 1. This is 3. This is 2, right? This is 4. This is what? 5. This is 7. This is what? 6, right? Now, where is 8? This is 8. 8, 9, 11, 10. 12, 13, 15, 14. You see what I did now?
Professor, I have a comment.
Sure.
Can't we use, so for the top row, can't we say, 0, 0? Can't we say that's C naught, D naught?
You can do that. Yeah. I mean, that's perfectly fine. I will tell you something. Here, right? This is basically the C complement, right?
Yeah, it helps me visualize when I'm simplifying. So I just thought.
Yeah, that's fine. Look at here, right? Here is A complement, right? Look at there. This is the A, right? Look at here. This is what? B, right? I can make it more visualized. Look at this. This is B complement, right? You understand what I'm saying? Because look, here is 1, here is 1, B. This aligned with B. Here is 1 and here is 1. This is A, right? For instance, here, right? Here and here. C is 1 and 1, so they're basically C, right? You can make it like this. This one and this one. What will come out of this? Gonna be D, and so on. It sounds good?
Yeah, it sounds good to me.
Yeah, it's perfectly fine. Okay, look, and also from here, there, that's actually D complement. Okay, look. Okay, anyway, now since we have 16, everybody agree? So that means what possibilities of grouping we can have? We can have 1, we can have 2, we can have 4, we can have 8, and we have what? 16. That makes sense? I'll give you an example. So we can make a table like this. 1, 2, 3, 4, 2, 3, 4, and then A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0. 0, 1, 1, 1, and 0. And then, I will fill it for you to be 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. All right, let me make some colors here and see what we can do. One of the examples I will give it to you, 1, 1, 1, 1, 1. So can you tell me how many groups you can have here?
3.
Your groups.
Any of you guys?
3.
Everybody agree with him that we're gonna have 3 groups?
Never mind. It should be 2. Yeah.
Should be 2 or 3?
2.
Who said 2?
I did.
3.
Who said 3? Somebody tell me the one who is supporting 3. Can you raise your hand or write yes or something? Frankly speaking, they are gonna be 2. Why?
2.
That's 1. And then, you know, this is the second.
Oh, oh yeah.
So that's group 2, and this is group 1. So maybe I will ask you guys. So basically, f as a function of a and b and c and d is equal to group 1 or this group 2, right? So let me check a name. Andrew. Andrew, can you tell me what is group 1 or G1 will be? Andrew? Maybe Andy can try. Andrew said something. So what you said, Andrew? He said AC, A complement C. So let's see whether that Andrew is right or not. So, you know, if we look into the horizontal vertical, so basically this is 1 like this and like that, right? So if I look to there, so that means I will find A gonna goes away with A, so gonna be actually B complement. And then, you know, if I go into the vertical, so gonna be like this. So I'm looking for the D complement with no D complement with just D complement. I'm gonna be D complement, right? So maybe I can ask you, Andrew, for the second one. So group 2, can you try to tell me what group 2 will be, Andrew? No, you're fine, you're fine. Maybe I know what you're talking about. You made actually group 2, right? So let's see whether that actually works. So, you know, here, if you go like this, so they're gonna be A complement. So, you know, Andrew's right. And then, you know, if you go like that, it's gonna be CD complement. Oh my gosh. A CD complement. No, you know what? Because, you know, look, this is the only horizontal way. So, right? So those guys are unique. So that's why you have to take them as
Professor,
yes.
so I just noticed that in a previous question,
Yeah.
we didn't do the same thing. You know how we got A prime right now?
Which one?
Did you see how we got A prime or A complement right now?
Yeah.
Not this one, the one before, we didn't do that step.
This one?
Yeah. Can you
Okay,
double
then.
check it? Do you see group 3?
Let's go for group 3. Group 3A is completely bye-bye. We just like go into what? This direction. This direction just have B and C. B is 1 and C is 1, so it's still BC.
Oh, okay. Okay. Thank you. Thank you so much.
You're welcome. Okay, so is it is it clear? I think we need to play a little bit more because I will tell you something about also the another element is called don't care, but you know, let's play with something else. So, you know, imagine that, you know, I have my table like this 1, 2, 4, 1, 2, 4, and they're gonna be X, Y, Z, W. Zero, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, 10. All right. Let me put some numbers here. Second, I'll give you a fancy number. Well, you know what? We can try this one. Look. How can we do this? We have 2 groups, right? So
Edges?
yes, how many of you agree that it's gonna be 2 groups?
I agree.
Yep, 2 groups.
1 and 2, right? So group 1, maybe I can ask Andy. Andy, what is group 1 will be?
Is it
Group 1 is gonna be the corner. So what is the corner again? It will be.
X complement, Y complement?
Let me see. No, actually, we know because look, we go like this, we go like this, right? In that case, you know, X is already by, Y gonna be is exists, right? Then, you know, we're gonna go into like this and like this. So basically, you know, W is 0 and Z is different. So that means they're gonna be W complement.
Okay.
So can you do the other one? The group 2? Horizontal like this. So what will be the output? Look at there, Andy.
Yeah. Yeah. So is that W?
They're gonna be W or Y?
Oh, Y.
Okay, and let's go into the
Vertical?
yeah, vertical. Yes, it's gonna be like this. So what would be
That's W.
W? So do you think he's right? Everybody agree that he's right?
Yes.
So what is this?
I just barely saw that.
Huh?
It's exclusive NOR.
Exactly. Look at this. It's fun, right? It's a piece of art. Let me find you something more fun, you know. This one is good. This is one I'm sure that you guys will like. Oh my gosh. I think that I got copied. Maybe X, Y, W, Z, 0, 0, 1, 2, 0, 0, 1, 0, 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 15, 8, 9, 12, no, it's not 12, 8, 9, 11, 10, right? So now what I'm gonna do, let me see. Look at this. How many groups should I have?
Professor, is it usually ZW or is it usually WZ? Just for like reference, because I thought it was.
It's whatever. I can. You know what? I'm gonna make another example with ZW.
Oh, okay, awesome.
Go ahead. It depends. Look. What I want you to understand is the following. When the table is like this, you go from the left to the right. That's it. When you go to the left to the right, look. So that means, you know, you go left to the right. So, you know, X, Y, and then you go from like this. That makes sense?
Crystal.
Perfect. Jimmy, how many group we gonna have?
4.
4. Can
Jeez,
you
that was quick.
one?
Oh, there's the 4 on the bottom, 8, 9, 11,
yeah,
10.
This is the group 1, right?
Yeah.
Okay, what is the second group?
There's 3, 7, 15, 12.
You mean this?
Yeah.
This is not 12, this is 11.
Oh, okay.
Okay, and then you know what is this group 2? What is group 3 it will be?
13 and 15.
mean those guys? Are you talking about this and this one, right?
Yeah.
Anybody agree with him?
Yeah.
You guys are sure?
Professor,
There should be two
Professor,
more.
No, you guys forgot.
do you want me to
I'm
start?
sad because look, this is group.
Yeah, it has to be group of 4.
Yeah, that's group 3. Now where is group 4?
The bottom
top
2
right.
right and the top 2 right.
Wait. Which one? Which one?
The top 2 right and the bottom 2 right.
All right. Make sense?
Yep.
Jimmy, do you think it makes sense?
Yeah.
Andrew. Okay. Now we need to write it down. I'm gonna be group 1, group 2, group 3, and group 4. Right? Let me ask you guys randomly. Let's see who I can ask. Benjamin, can you tell me what is group 1? Benjamin, you said what? Gonna be X? Based on what? Andrew, look at this, okay? Look at this. You go horizontal, right? It's gonna be XY. XY complement. Right, Linda. So Luai and Benjamin, do you understand what I'm doing? So, look at the line, this line is just covering those, and those guys are unique, so you have to take them as it is. X is equal 1, so that's Y is X. Y is equal to, that's actually Y complement, right? Is it clear to the rest of you guys? Gloria, does it make sense?
Yeah.
Okay. Now let's go into the group 2. So what is group 2 we said? Group 2. So group 2, it has 2 directivities, right? So let's go into the first directivity. So this is the group, right? So if I go like this, I'm covering what? So what will be the output from the horizontal perspective?
X.
X. What will be the output from the vertical perspective?
Z.
Z, correct. Let's go into the group 3. So where is group 3? That was a group 3, right? So we need group 2. So we need group 2. Where is group 2? Where is group 2? This is the group 2, you mean, right? So the group 2, if you go into the group 2, is basically horizontally, nothing will be there. So the only thing, it will be vertical, right? So it's gonna be what? It's gonna be
WZ.
Z. Then what is the group 4 will be. So let's see what is group 4. So group 4, let me find a different color here. So it's gonna be like
Y
this.
complement.
So it's gonna be Y complement, right? And then what is the group in
And then W.
So what is gonna be? It's gonna be W.
W.
So everybody agree with us? Does it make sense? Anybody have any objection?
Wait, so which one was the yellow grouping again? I didn't catch that. The one that goes across?
This guy, you can see, is like this.
Right. And which one was that one again? The one that you guys wrote?
This is the last group 4. So the group 4, if you look at it, if you go into this direction, you end up having what? Y and complement.
Oh, yeah.
That direction, they're going to be this one and this one, which is basically W.
For grouping, like our group for group 4, what are the rules around grouping like that?
Because, it's, do you remember when we said the Earth like this? And
Yes.
also the Earth like that. That's why it's like, I'd say it's like a sphere.
Oh, okay. So if there were the two in the like top right, like the top right, and then like bottom, like middle, top right, and then top left and bottom middle, top left, then
Yes,
like it would be a group.
yes. Let me make something more fun. What do you think about this one? How many group we're gonna have?
One.
One.
Why? Because you know the Earth, right? So like this. You guys agree? So if I look to the horizontal, it's gonna be this, which is what? End of the day, it's gonna be here y complement. Vertical, everything gonna go w and z gonna go by, right? So in that case, you know, the whole entire thing is representing y complement. That makes sense? Jimmy, make sense?
Yeah, it makes sense. Thank you.
You're welcome. Anyway, let me find you another example.
Professor, can you scroll a little bit up?
Yes, here?
Thank you. Yeah, right there.
Sure. You have any question?
No, I'm just making sure I figure it out in my head. Thank you.
No, take your time, take your time. You know, we're no rush. Yes.
To ask you a question, what does a test question look like on this? Does it give you the table like we're looking at right now and says?
Oh, basically the questions will be. It depends. It depends on the design. So basically, sometimes you know we can have a design problem. Like, do you remember? Did you see the problem that I mentioned? The design three inputs majority encoder. In the beginning of like building up midterms and quizzes, question like that, it can be simplified this. I can give you a certain equation and say simplified using K-map. But later on, you know, because you know this course is accumulative, right? So you know you're gonna make a design problem. So normally in the design problem, think about it, right? You're gonna think about how can you make a block, like what you did here, right? And from there you make a truth table, and from after the truth table you have to go in optimization. So that's why you have to use K-map. So K-map will be used no matter where, and then you know you will go ahead and you write the equation, and from there you're gonna figure out what is type of gates you're gonna use based on the question, and you will make a full implementation, and maybe I can ask you for the longest path or the critical path. That makes sense?
Yeah, makes perfect sense. You said full implementation.
Yeah, or design. When I say design, that means you're gonna go full implementation.
Okay.
That makes sense? Okay. Let me find. I need to look at one example which you guys will know. Okay, here is the thing I need to tell you about, and we're gonna practice it more next time, right? Have you seen this before?
In X?
Yeah, that's just, see, you said X, right? But in the symbol wise, in the Boolean algebra, that's called don't care.
Oh, yeah.
So any digits can be actually 4 categories. Can be holding 0, that means connected to the ground, or it's connected to the voltage source, that's called 1, or it's I don't care. Either gonna be 1 or 0, it will not affect on me, or you can have it floated, so there is no ground or nothing, so that they call it Z, high impedance. So look at the type of data. It can be 0, can be 1, it can be X, it can be Z. Okay? What is the most important direct impact on us in K-map is basically the 3. I give you an example now, which is 3-bit variables, and you know we can discuss about it. So I have here like this: 1, 2, 3, X, Y, Z, 0, 1, 0, 0, 0, 1, 1, 1. 1, 0. 0, 1, 3, 2, 4, 5, 7, 6, right? Let's imagine, I'm just putting now just an example, right? So let's imagine that, we have x, 1, 1, 0, 0, 0. So how many groups we should have?
Just one.
Maybe 2.
How many groups should we have?
1.
1. Why?
Can you group don't cares, right?
I will tell you, 1. Tell me what is the group, what is the boundaries of this group will be?
I think it's 0, 4, and 2 and 6.
Who's actually answering me?
I'm sorry?
Your name, I didn't see.
Oh, Melvin.
You are right, because, he is right. Look, so basically it's a 4 spots. If you think about those 4 spots, you will find out that, it's a full location, because, X's, we don't care. So when we will need it, we will use it 1, but if we don't need it, we'll put it 0. You see what I'm saying? So again, those X in the table will be 0 or it can be 1. It depends on the location. So if you want it to be 0, put it 0. But if you want it to be 1, put it 1. It's better for you to group as many as you can to get better optimization, less number of literals or less number of variables. So in that case, if I just group 2 of them, I will still have 2 literals. But end of the day, when I will go ahead with 4, I will go into like this directivity, then this is gone, and then I will just have Y and Z. Sorry, I will have, I'm sorry, I will just go like this. So gonna be
Z0.
So have you noticed? So from having just not gates used for the 1 literals, right? Because we have 4, we would be ending up having, n gate. So that will be better in terms of optimization. That makes sense? You guys understand what I'm saying?
Mm-hmm. Yes.
Okay, if it's clear, write clear on the chat. Yay, it's clear. So let's have a different example. Let's have it like this. What should we do? How many groups we can have?
2.
2.
Actually, 1. I think it's 1.
Who said 1?
Melvin again.
Huh?
I would say 2.
Who said 2?
Wait, never mind. 1. Yeah. 1.
Make your mind up. 2 or 1? 2 or 1? 2 or 1? 2 or 1?
1.
1. Where is that 1?
3 and 7.
And what about those guys? What should we do with those guys?
We don't care.
We don't care.
We don't care. Exactly. So, it's a 1 group. Yes. So in that case, it's going to be YZ. Right? Let's have it in the 4 context. And then, we're going to practice more next time, okay?
I think we need one more row.
You're right. We optimize it,
I was gonna say, do we just not care about the last row?
It's not bad. It's a very good approach, 12, 13, 15, 14, 8, 9, 11, and 10, right? And what I want to do is yes, what should we do with this situation? How many group we should have? Excuse me.
Two. Yeah.
2. Somebody tell me what is the group number 1 will be.
048.
Wait. 0, 4. Where's 4?
Under 0.
Okay, that one. And then?
8.
No, I will tell you something more fun. This is 1. Do you agree?
Yes.
Yeah.
Huh? That makes sense?
Yeah. Yeah.
Yeah.
Look at the second one.
It's yeah.
2 groups, right? So this is group 2, this is group 1. So if this function would equal group 1 or this group 2, so in that case, what is group 1 will be? So if we don't know, we just do like this. So basically it's gonna be X complement. And that's it, right? Because in the top we're gonna be removing each other, right? What is group 2 will be? We have done it many times, so.
Y complement, Z complement.
Z complement, Y complement, yes. Let's make implementation for this. What the implementation will be? Using NAND gates. So it's gonna be like this, right? Gonna be like that, because this one is equivalent to what? This is what? If you remember,
Why?
you can flip this one to be like this. Sorry. Right?
Yeah.
Makes sense? So here's my Y. So that's basically gonna be Y, Z, like this, and like that, and then like this, right? Then that's all. What do you guys think? Is there any optimization out of this?
You can cancel 2 nans right there
Right?
as well. Yep, there you go.
That's it. So did you see what we are doing? We are putting everything together. So, we learn number systems, we apply the number system, we build gates, and we learn Boolean algebra. Now we are learning optimization. Now we are using the optimization to build a circuit using whatever we learn from the gate equivalents. Does that make sense? What I would expect you guys to do, you will look into the problems in the back of the book, of the chapter. We are in chapter 3. Do you know that, right? Which is gate level minimization. Let me find your problem there, and we can do it together. So, not that many actually there. So, like one of them is say here. I can make one example with you guys. Okay. So that's actually from the book, right? It says find all the prime implicants. So you're gonna build the optimization of the x, y. No, he made it different. He make it like this: w, x, Y, Z. So this is the order from the left to the right, right? It's equivalent to sum I is equal to 0 to 15. And from there, we can come and say it's going to be 0, 1, 2, 5, 2, 5, 7, 8, 10, 15. Okay, and we are looking for the optimization. So in that case, we can just make our K-map 1, 2, 3, 1, 2, 3, and they're gonna be W, X, Y, and Z, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0, 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14, right? Now it's 0, now it's 1, now it's 2, 5, 7, 8, 10, and 15. And those are zeros. What should we do? Somebody tell me what we're gonna do. I can make it easy for ourselves. This is group number 1, and this is our favorite one, right? Everybody agree?
Yes.
What should we do with the others?
Can we group 0 and 1?
You can, but since it's some others can finish it, so this can be grouped, right?
And then 7 and
7 and
15.
5.
And they're gonna be
15.
grouped, right? So that's 2 and that's group 3, right? Because there is no need for redundancy to group those already grouped, right? So
Yeah.
us. That makes sense. So that what the question I gave it to you, it was 339 in page 119, and that was an element F. If you were really interested in going into these problems, But in general, so is it straightforward to everybody? So we're just gonna have we're gonna have just have 3 groups, not 4. Okay. Anyways, 8:15.
Sounds good.
I know that you guys might have also other classes or so. So if you have any question, please don't hesitate to tell me. Okay. So the coming Monday, we can maybe practice a little bit, tell you something about what will happen in the first quiz. Pretty much, I don't want to be too much on you. So the first quiz, what I'm gonna do, I might give you the quiz with you. You take the whole entire day, you work on it, and then I will tell you what is the procedures on Monday. So it's very straightforward. It's very easy. You're gonna have fun, I promise you. There is nothing will hurt.
Thank you, Professor.
So please,
Thank
guys,
you.
if you have any problem, if there's something is not clear or you're afraid of something from the materials, just don't hesitate to contact me. I would be more than happy to assist you. Sounds good?
Great. Thank you.
Thank you.
Stay safe, Professor.
Thank you. Appreciate it. So God bless you guys. Okay.
Thank you, Professor. God bless. Bye-bye. Thank you.
Bye.
Thank you, Professor.
Thank you. Thank you. Have a good one.
Wait, a question. Sorry, actually, I might as well use this as a time to answer the question in front of me. 5 and 7. Why did you connect those if there's only 3 groups? There's only 3 groups, correct?
No, there is no 5 and 7. I said, you need to do it.
Oh, okay, I'm like, that doesn't make sense to me. Okay, thank you.
Yeah, see? Okay.
Yeah.
Thank you.
Awesome.
God bless you.